My name is Kaylin, and I'm a part of Unity Diversity Recruiting Team as a project coordinator. I am super excited to be here with you today with my teammate for tonight's workshop. So I'm not going to talk too much, but without further ado, I want to welcome Thomas. Take it away.
Hey, hi, everybody. So if you are here live or watching the recording, welcome. Glad you're here. The link you can see on the screen here, bit.ly/Conexion demo. That's how you're going to download the assets to follow along. I'm going to leave those up there so you can follow along, even if you're watching a recording or a later segment. But let's jump into this thing and get it going. So my name is Thomas Winkley. I'm a technical marketing advocate here on the academic and nonprofit team at Unity. And my job is to work with nonprofit organizations, academic organizations, and different schools and teach people about Unity and the power of real-time 3D. So the first thing I want to do when I dive into this type of thing is talk about, well, I guess introduce myself more first. Don't even know my own presentation. A couple things about me. I like to make games. It's kind of why I'm here. I like teaching, which is another reason I'm here. My favorite genre of games would be fighting games. Second would be JRPGs. And my favorite food of all time is pizza. It's what I eat everywhere I go. It's pretty tasty, and it's fun. You can learn a lot about a culture by the pizza you eat. So jumping in, I want to level set a couple of things about what we're going to be talking about today. So a term you're going to hear a lot is real-time 3D. And this is the ability to quickly render detailed 3D images. So you can basically take the term quickly, replace it with real-time, and ta-da, you've introduced the thing, right? And real-time 3D is, the industry we find ourselves in. That's what we call the technology that we build and work on. And engines or platforms have a stack of included solutions that let you focus on building things and not the minutia of building things, if that makes sense. So instead of having to figure out how light bounces off of a metallic surface or how a rock dropping hitting another solid surface would bounce, we have those things ready to do it for you, right? We have the physics system, we have the lighting systems, and now you can start building really fun, interactive, exciting experiences without resolving the stuff that has been solved by this industry multiple times. So this rendering has improved a lot in the last 30 years. This is a shot of one of my favorite video games of all time, Final Fantasy VI, came out on the Super Nintendo in like 91. And this is a 16-bit rendering system, right? You see that you've got like some really cool God rays coming in with the yellows blended with white. You've got reds and whites blended to make the pinks and purples coming here on the back of Kefka. And they're getting quite a lot out of that 16-bit rendering system, right? But if we jump forward and look at a game like Ori and the Blind Forest, we see that it looks even better, right? Now we've got this beautiful depth of field. The light is actually impacting the different thorns down here. You've got this glow effects coming off of each of the light sources. It looks really clean. And then we move forward to something even more powerful. This is a shot from a short film Unity did called Enemies, done in real time. And you have this incredibly powerful shot, right? You've got the real-time fire simulated here. You've got this incredible depth of field where the main actress is actually blurred out of the background completely. And again, all of this is processed and adjusted in real time. So that's what we're talking about when we talk about real-time rendering or real-time 3D and what we're building here. And with that, I want to make sure to cover a few things in case somebody might be new to the games industry or maybe not might be trying to switch careers completely. Let's show you some of the things about it. So let's jump on some key terms. So first of all, let's talk about sprites. Sprites are images that represent game assets, right? You're probably familiar with like Mega Man or other 2D games. Those are created by sprites. And what happens is they're put onto a sprite sheet. And a sprite sheet is a bitmap image file that contains several smaller files in a grid arrangement that you can slice up and create an animation, sort of like a flipbook. So if you look at this running animation in the bottom right here with Mega Man, all that is a series of sprites in different states that are being flipped across frame by frame to create that running animation. Sprites are also really useful for UI and that type of thing as well inside of the engine or any tools you're working with. Now, a primitive is a basic 3D shape in Unity. So this is going to be like cubes, spheres, capsules, cylinders, planes, quads. Those are the ones you can build with. And we use these a ton to either rough out environments or shape things out or do what we call gray boxing. Or sometimes we combine a bunch of primitives to make the objects we need because they're the basic shapes or basic building block of what we're working with. Now, a mesh is a collection of vertices and edges that make up a 3D object, right? Those are the faces you see. And a lot of times, if you're a little older like me, we talk a lot about like the polygon count or the poly count or the tri count. And that is how many triangular faces make up an object, right? And those are all represented by vertices, which is then connected to have a face. And that's how the renderer knows what to show on your mesh. A material is something that can be applied to an object or mesh and define the visual look of that object. So what color is it? How reflective is it? Is it semi-transparent or is it opaque? Those types of things are what a material defines, and those take place where the material gives values to a shader, which then makes all those things happen inside the engine. All right, I realize this is a lot of data. We're gonna take a 2-second breather. Okay, we can move forward now. So let's talk about the asset pipeline in game development and how that works. So first of all, you have your model creation, right? 3D models are created in something like Maya, ZBrush, Blender, 3ds Max, any other litany of tools, right? That 3D mesh object. From there, it's sent off to be textured, and it can be textured in Substance Suite, Quixel, Art Engine, Photoshop, anything that allows you to paint these 2D maps called texture maps. And at the same time, it can actually be rigged and animated instead of Maya, Blender, Mixamo, right? Where you actually put a skeleton into it and move it and adjust it so that it runs and does the different animations you want. Once all that's done, it's recombined and it's brought into a game engine like Unity. So then you have your animation clips, you have your animator, you have your textures, you have your model, you have everything you need to start moving and scripting those interactions. Now that's changing and it can adjust a little bit. Like you can actually create animations inside Unity now, but we're talking like standard AAA industry workflow, kind of how it goes there. Now in the world of 2D, you start with sprite creation, right? We've got to create those 2D images, and that's done in like Affinity Photo, Photoshop, Spriter, ASC Sprite, anything to let you create and generate 2D images that you can put on a grid and create a map of. And then those are actually made into a sprite sheet to animate, or inside of Unity, we have a 2D rigging package that you can actually rig and animate them. You can also set the different body parts to be parts of Photoshop layers and then animate those. There's a lot of different choices there, but they're essentially rigged and animated in the 2D sense, and then brought into Unity to create those interactions and start doing stuff. So now that we've kind of gone over that primer, let's actually jump into building something. Let's create something for real. So I already have a Unity project open, but just in case you don't, let me show you how to do that really quick. So I'll pull up the editor to make sure my screen share is correct. It is perfect. If you can hear my dogs barking, they say hello. Somebody's probably walking down the street. So first things inside of the hub is where you create your new projects. So on the top right, I'm going to go to new project. I'm going to choose 3D URP. URP is a rendering pipeline that we have here at Unity. I'm not going to dive into it very deeply, but this is what it is. It's URP. It's a great place. Great rendering pipeline. It's also very good for mobile and all kinds of optimized experiences. And I'll call this Latinx Gaming, and I'll hit create. And then from here, it's going to boot up a Unity project, get all my scripts compiled, and you should see a screen like this. We're just going to hang tight for a second. While that loads up, I'm going to talk about a couple of things, and then we'll go back to actually creating primitives and working through that part of this presentation, okay? So let's jump back over here, and let's talk about game objects. So game objects are the basic building blocks in Unity that represent characters, props, scenery, user interface. Anything you're going to do in your game starts at a game object. And it doesn't accomplish much by itself, but applying components to it gives it the ability to then accomplish things. Components are really what implement functionality inside of Unity. So you might see a lighting component or a mesh renderer component, maybe a transform or an audio source, those types of things. And transforms are really, really important to Unity. They're actually like the most fundamental component in my mind. They are on every single game object in Unity. Every game object has a transform, and a transform stores three things: position, rotation, and scale. Where am I? Which way am I looking? And how big am I? Which is the fundamental essence we need to know about all of our game objects. This is really helpful. If you've ever used a lot of Adobe products like After Effects, that actually, using Unity made me better at After Effects because I realized how transforms function in Unity, and then I could just transfer that knowledge over. It's a pretty standard term, but we always want to know those three things about our game objects, specifically if we're playing in like a 3D experience. So I mentioned this before, but some examples of components are transforms, cameras, lights, input system stuff, mesh filters, renderers, materials, and actually custom scripts we write in Unity can be used as components depending on how we set them up. All right. So now that we've done that or talked about those things, let's actually create a few objects. So this is my new URP scene. I'm going to select the main camera just so my inspector changes over. But the first thing I actually want to do is in my hierarchy window, which shows me everything built in my scene. And a scene is a data container that contains basically anything active in my current situation. I'll hit the plus key right here, go to the 3D object, and I'm going to start by creating a plane. So a plane is just a nice flat surface. You'll notice it turns blue for a second while the lighting generates, and then I get that generic kind of gray plane right here. So once I've created that, you'll notice in the inspector with it selected, I can see all the components attached to a plane to make it act like a plane. So we've got the mesh renderer, which tells the camera, hey, this is what I look like. We've got our mesh collider, which says, hey, this is where I am, and physical volumes can't move through me. And then we've got our material, which tells us what color we are, which right now is this generic kind of universal gray. And that's how you create a primitive. And then we can scale things up and change the sides. If you also want to create a primitive, you can right click inside the hierarchy and go to 3D object and choose another one. Like maybe I'll make a capsule. And then I'm going to select it. I'll hover in the scene view and press F to frame it up. You can also double click on the object itself to frame it up like that. And I'll grab the Y axis on the move tool and just kind of scoot it up a little bit. Okay? But that's how we create primitives. So pretty basic stuff. I'm going to give you just a second to do that in case you are following along with the recording. And I'll leave up the instructions for just a second so you have a good place to pause at. Bloop, bloop. So here's how you create a primitive. And if you're watching a recording, you might want to pause it slowly, make a good pause face. Okay, cool. I'm going to keep rolling and we'll keep moving forward, all right? So now that we've talked about game objects, let's actually talk about importing assets. So one of the things you're going to do working with the real-time 3D engine or as a game developer is you need to share assets to other colleagues, maybe other people working on your project, maybe you need to transfer them to a new computer. And one way you can do that is with the Unity asset package. It's essentially a fancy zip file that allows us to pull that data in. And so I've provided one for this workshop, but if you remember at the beginning, we had a link you could download it from, and we're going to import that. So all we have to do is go into our project window and we'll follow these steps. I'm going to go back to Unity. And inside my project window down here, which gives me access to everything available inside my current project, I'm going to right click and go to import package, custom package. And then I'm going to look in my downloads folder and I should have, maybe it's on my desktop. See if any of my, look how many assets I have. I do a lot of demos. All right, looks like I didn't download it yet. So I'm going to go to the link that I told you to go to. We'll download it real fast. Wait, hold on. Is this, all right, well, we'll get it fixed. For those that are going, wow, this guy doesn't know how to use computers. It's the end of the day. Have a little mercy on me. Only because it's like 5 p.m. And I only have the ability to think for like, I don't know, 4 or 5 hours a day before I just get like cooked. All right, here we go. Downloaded the file. We're good. Wait for this to pull down really quick. Done, deal, and then we'll pop open to the folder. Okay. So now that I've done that, in my downloads folder, again, right click, import package, custom package, go to my downloads folder, you see Conexion demo, and I'll hit open right here. And we'll give it a second. And once I do that, you'll actually see this import window here. So this import window tells you everything you're bringing into the project. And you'll notice I have this new tag on the right. That's because most of this stuff has not been in the project yet, and we have a metadata file to tell us that. Now, if you scroll down, you'll notice that I have this, my scenes. There's a couple that say, hey, like this folder is actually changing. This sample scene is going to update. It's going to be changed or different. And that means that I'm just importing a different sample scene. So we actually give you a warning to let you know so you don't overwrite anything. I am actually going to uncheck sample scene so that I don't overwrite my current one. Everything else should be fine, though. I'm going to hit import and let this finish. All right. I'm going to pop back up these instructions again. And if you're following along, great time to pause, jump in, undo this. I'll do another good pause take. Okay, cool. Hopefully everybody watching live is following along okay. And we'll jump to the next part. So now that we've imported things, let's actually go back to building. And we're going to expand out our world just a little bit. We're going to move some things around. And we're going to set up some obstacles for a vehicle to drive across. So first, I'll select my plane. I can do that by clicking on it inside the scene view or in the hierarchy window and click there. And if I look at my transform, I can change the scale. Now, the scale is in X, Y, and Z. And if you look at the select tool, you'll notice that there's axes going each way, right? So the red axis is the red axis is X, the blue axis is Z, which is front to back, and then the Y axis is up and down, it's the green. So being that this is a slim, basically 3D thing, but it's very slim, we don't really need to expand it in the Y direction at all, right? But I am going to expand it by 5 in the X and 5 in the Z by clicking inside here and just typing those numbers in. And then I can actually hover and zoom out with my middle mouse button. And you'll notice that I've just made our plane a lot bigger. So we just have a lot more room to move around and do stuff here, right? Then I'll right click here and let's create another 3D object. I'll do a cube. And you'll notice that if I double click on the cube, I frame it up, it's kind of appearing in a weird spot. So I'll make sure I have my move tool selected here. You can push W or you can click on this button. And I'll just start scooting it around by the axes to kind of create some obstacles around the area. I'm also going to make the cube bigger. This time I'll use the scale tool. So I'll click here, or you can press R for the shortcut. And I'm going to click in the middle and just kind of do like a manual scaling so I can make it a little bit bigger. And then we'll grab some stuff and move it up. Yeah, that looks like an obstacle. And then, you know what? Spheres are always fun to play with in driving games. So I'm going to make a sphere. And as you're working on this, you can make as many objects as you like. But that's going to be your next part, is make a couple objects to spread around the scene so we have something to kind of mess with as we drive our car around. And we'll R to scale that up too. Yeah, that should work. Okay. So set your scale value to 515 on the transform inside of the plane. Create a few other primitives and move them around the plane so you've got extra objects. Remember, you can get to the move tool by pressing W or clicking on the move tool, which I have highlighted on the screen here. And then if you want to scale it up, the scale tool is just below it right there, or you can press R for the shortcut. And if you're following along in the recording, good time to pause. And then we're going to move forward on it. And if you're following along live, let me know if I'm going too fast. I'll give you like a minute or so to get through that. Okay. So now we actually want to add some color to our scene, right? As we're looking at it, it's pretty much just gray. It's all we're seeing is gray. And this is where materials come in to tell the renderer what color it's going to be. So inside our assets folder, I've got some folders defined already. So first I'm going to right click and go to create folder. And I'm going to name the folder materials. Now I accidentally clicked inside my prefabs folder, so I can left click and drag this out to the assets. But if you go into the assets, right click, you can create a folder right in there. And I'm naming it materials. Now, the reason I'm doing this is it's really important to organize your projects well early on. Good folder structure, good project organization is really important to anything you're doing with software development. And in games specifically, your projects are going to start growing and getting bigger and bigger at scale. And if you don't keep your project organized, you're going to have a hard time later on finding the stuff you're trying to work with. So double clicking materials to open it up. I'm going to right click here, go to create and select material. Bloop. And then we'll call this cube material. Bloop. So now doing that, I've made a new material. And if I look in the inspector on the right, I have these surface inputs right here underneath my material component. And I can start choosing how I want to define those. So if I select this white color picker, and I can start choosing what color I want my material to be. So I'm going to start dragging it around here and dragging it around here. And it looks like we have someone in the waiting room, so I'm going to let him in real quick. Cool. All right, so we've got this created here, and we've got our new material. We've defined the color as kind of a purple. Actually, that purple's too close to the missing material color, so I'm going to go back to let's do like a blue. And then I'll drag this onto my cube. So to assign it to the object, you just left click and drag it onto the object either in the scene view, or you can drag it onto the object inside of the hierarchy view like this. So now we've got like a blue cube. You can also play with some of the things. Like if I want this to be more metallic, I can make it a lot smoother so that it reflects light better, and then drag that metallic map over. And now you'll notice this looks a lot shinier. You can kind of change and mess with those inputs to adjust. So I'll probably bring the smoothness down to about it here, and I'll probably make it less metallic, like maybe like that. Okay. So Make sure you do that. Change your unfurl the surface inputs once you've created your material. Select the color rectangle and next to albedo, choose what color you want, and then you can left click and drag it onto your object in the scene view so that you can change the color or something. And of course, you're welcome to experiment and make more materials and add this to more objects as well. Thank you for dropping that link, Kaylin. For those who just joined, if you're following along, that link will get you the demo assets to follow along with. There'll also be a recording so you can catch up later on too. And we'll give it just like 1 minute to kind of follow along and catch up real quick. Kaylin, how you doing so far? Am I going too fast for you? You able to keep up?
Well, I got to making 3D and I guess objects. Yep. I could not figure out how to get them color, but they are on my plane.
Perfect. So if you follow the steps on screen right now, that will add color to them. So this is the actual, so materials are what add color. Yeah. So if you jump on that, you'll see it right away.
All right. I'm gonna try.
Cool. Do something real quick. All right, so now I'm going to jump forward to the next step. We'll move kind of forward so we can get through this in the hour. But now we want to start talking about interactivity. So we want it, like right now we just have a flat plane, and that plane has some objects on it, right? But there's not a lot going on. So we actually want to make it so that we have something to do. So the first thing we're actually going to do is put a car in the game, put a vehicle in the game. And in this asset pack, I've actually included a couple of vehicles. So if you navigate to assets, course library, vehicles, you'll see a couple of choices. You've got like a red car, a blue car, a ute red car, and then a green van. Which one I should use this time? What is this one? Oh, I'll use this, buddy. Oh, and look how purple this is. What an opportunity to talk about fixing shader issues. Huzzah. So what we can do to fix these shader issues, if you go to the materials folder, bloop, it's actually inside the source files, materials, military props, military green. Did I delete the materials? Where's my material? Simple town material. Oh, there we are. Change that shader to universal render pipeline, lit. Everything will look better, not purple. Huzzah. All right, so this is our blue car. It's okay. It's blue. It's a car. But that's step one. So we're going to add this here. And now we want to actually add a custom component or a script. So we're going to add something that we've already written. So I'll select the main camera. And I'm going to click add component. And I'm going to search for camera follow. And you should have a little script here called camera follow. Now, this is something I set up previously that we can use as a component. And it has an offset and it has a follow object. So the follow object is a field we need to assign. And we'll talk about how to do that in just a second. But first, add a vehicle in the project window, select the main camera and click add component, search for camera follow, and then you're going to add camera follow.cs. If you get stuck or have questions, feel free to yell at me in the chat. We'll give it just a minute as we catch this up. All right. So once we've clicked on the main camera and added that component, you'll probably see a couple things. So we've got some fields here. So this follow object, this is a field that says, what am I following? What object am I following? And since we're making a driving game, we want to follow the car. So if I left click on my car and drag it over, I can actually drop it right into my camera follow script like this, and it'll assign it. If you're having trouble doing that, you can click this little cog right here. And in the scene view, just double click on the car right there and it'll assign it as well. The next thing we need to do is set up this offset. So the offset is how far away from the car am I going to be? And surprising nobody, maybe somebody, I've pre-calculated this value just to make it easier for the workshop. So if we set the Y value to 5 and the Z to -10, will actually be about 10 units behind it. And then if we take the rotation of our camera and set the X value to 30, it's going to look weird right now. But what you can do to test it is if we set the position to 5, -10, like this, you can kind of see that it actually is a pretty good view of the car from a game perspective. Now, there's a strange angle here, but actually when the snapping happens with the code, that will fix it because our code is telling it to do so. It's probably because our car isn't actually sitting at 0, 0. So we could just do this, and then we would see that it looks like nice and centered and nice like that. But so again, just to review those steps. So on your main camera with your follow object, you're going to add the car to it by either clicking this cog and selecting from the scene tab your vehicle, or just left click and drag it in. And then set these offset values to 5 and -10. We're just configuring a custom component that somebody's written for us. Let's jump to these steps real quick, and then we'll actually talk about the anatomy of a script and what makes up a C# script in Unity. And that'll actually give you something nice to follow along with while you're working on these steps. You can catch up while I talk about the anatomy of the script a little bit. Of course, if you have questions, feel free to yell them at me in the chat. You don't have to type in all caps, but you're welcome to. If you're watching this recorded, sorry. I may be powerful and sentient, but I am not sentient enough to know that you're watching a recording. Okay, so now that we've done that, while you're working with that, let's talk about the anatomy of a script just a little bit. So this is what a basic C# script looks like in Unity. C# is the programming language that we use in Unity to build everything. So first of all, we've got our using statements at the top. This is just telling the script, these are the things I need access to. This is where my tools live, okay? Then at the top, we have our class declaration. This is us saying, hey, this is the name of the class, and this is anything that it follows. So this is our camera follow script. It's a camera follow class. And we named it that because this script makes the camera follow something, right? Then we have our variables. So these are the variables we have available in the script. So remember populating those. We have this vector3, which shows X, Y, and Z, and that's our offset. And then we have our game object, which is the follow object. So this is, hey, what game object am I following, right? Remember we talked about this, that game objects are the basic building blocks of Unity. And so we're just saying, hey, there's a game object in there I want you to follow. Which one is it? And we can assign that. And then we have our function here, or our method. This is a set of instructions that tells the script what to do. So this is saying, hey, during fixed update, you're going to set the position to the offset position, basically. I don't want to go into too much depth, but fixed update is a constant thing in Unity. It is a script or a function that runs every physics step. And we also have an update function, which happens every frame. So these are things as a developer you use quite a bit to tap into certain pieces of Unity. So that's kind of the basic anatomy of a script, right? We have the class, we have the variables, and then we have the functions that do the work that we need it to do with our variables. Okay. So now we actually want to make our vehicle drive around. So what we're going to do is we're actually going to set up a vehicle controller script that's also pre-written, because I want you to get really comfortable just adding components. And then we'll actually use visual scripting to create our own interactions separately after this. So if I go back to my scene view here, make sure my vehicle is selected, and in the inspector, I'm going to go back to add component, and this time I'm going to search for vehicle controller. And there's a script called vehicle controller pre-made. So if I click on that or hit enter, it'll add it. And now we have this vehicle controller pre-made script, and it has a speed and a rotation speed. And to show you that this is how scripts look, I am going to click here and go to edit script, because I just want to show you a script outside of a screenshot. So if we look at Visual Studio here, maybe as this loads, you can see the same thing. So we have our vehicle controller pre-made as our class name. Here's our 4 variables. We're actually not using the start function at all because this happens before the first frame update. And then instead of update, we're actually doing some input handling and moving stuff around, okay? But again, same basic outline as we showed you with that camera follow. Variables, function, class, and it works. So now that I've set that, I have my speed set to 5 and my rotate speed set to 5. I'm actually going to set the speed to like 25 and the rotate speed to 15. Then if I hit the play button, it's actually going to run my simulation and let me play the game. So using WASD, I should be able to move around. And you're going to see it be a little bit choppy, and that's okay. I'll show you how to fix that here in a second. It's actually because of the way the camera follow script is working. But it's moving, and we can now drive into stuff. Now you'll notice that I can drive through some of these objects, and that's something we can fix here in a second. But we at least know our car is moving, and that's part of the fun. Okay. So I'm going to jump back, throw this up here. So set your rotate speed to what you like and your speed to what you like. I did 25 and 5. You can do 10 and 5. You can test different speeds and then hit the play button to test. And then when we move on in a second, I'll actually show you how to fix that jitter we're having. Oh, yeah. And if you're watching the recording, good time to pause. Cool. Okay. So let's talk about the jitteriness that we were experiencing really fast. And I'll show you because we need to edit the script to fix that. So if we look at our car and we go to this pre-made controller, we'll go back to edit script again, load it up inside of Visual Studio. You'll notice that the camera follow script is updating on fixed update, I believe, and this is updating on update. So what's happening is every frame, the car is moving, but the camera is only updating every couple of frames. I think it's every 8 frames. So you're getting this weird jitter effect while they're not syncing together. So theoretically, if I change this to fixed update, so that they're actually updating at the same time, that should fix my issue. I'm also breaking like my cardinal rule, don't try to troubleshoot stuff live, but I'm pretty sure that's what the issue is, so we'll find out. Either that or you're going to have a recording of me being totally wrong. Nope, looks like it worked. Nice and smooth. Hey, look at that. And then all we need to do is make it so we can crash into stuff, which all we need to do is give the car a rigid body. So if you want your car to crash into stuff, another component you can get access to is called a rigid body, and it's what tells Unity to treat the car as part of the physics system. So again, if I click here, go to add component, type rigid, I'll see a rigid body. Make sure you add a regular one, not a rigid body 2D. But now this means the car will obey gravity and physics will take place. So if we activate this again, now my car crashes into stuff. And the crashing is a little bit weird, mainly because we're not using physics-based movement, but still fun, still exciting. Okay. Bloop. Okay, so that was a troubleshooting bonus moment. Hope everyone's doing okay so far. Hope you're enjoying yourself. Let's scoot along to the visual scripting portion. So what we actually want to do now is create our own camera follow behavior using Unity visual scripting. So visual scripting is really cool and really powerful because it's another way of writing functions and getting stuff to happen inside of Unity without writing text-based code. And one of the goals of here at Unity is to make sure everybody has access to our technology and can build it, whether you want to be a programmer like myself, whether you just want to do more of the art side of the house, or maybe you just want to use visual scripting for quick prototyping. Wherever your use case is, we want to make sure we're there to help you and support it. Yeah, so that's what we're going to do with this. So the first thing we have to do is click on my main camera and go back down to this camera follow script I added and click on this little kebab menu here, which I just automatically opened. But I actually want to click on that and remove the component from my camera. So I'm going to close the script that I accidentally opened, click here, and hit remove component. So that'll get it off the screen completely. So now we need to create a C# script, right? So we need to add a script machine. So to do that, with my main camera selected, I'll hit add component again. You're all going to be very tired of that button. And I'm going to search for visual script. I think it's actually called script machine right there. Pop that up. And now the script machine is created here, okay? And then we'll have a source, which is our script graph, which is where our code lives. And then we'll have our variable declarations. And I think we're going to add some variables here. We're not yet. We're just going to go nice and easy. So we're going to go down to this script machine. And in a second, we'll actually create a new, we're going to click create new right next to the graph. And I should have a folder called scripts. And inside there should be a visual scripts folder. And I'm going to call this camera follow VS. So I know it's a visual script. And then that's going to give me this visual script machine here. And in the title, I'm going to call this follow game object. And then in the summary, I'll say follow assigned object. And again, I'm just documenting stuff so I know what is there, right? To make sure we can create this follow behavior. Okay. So if you're following along via the recording, I will You can pause, good time to pause, and then you can jump forward here. But we're going to name it camera follow, describe the summary, and get that all set up. So yeah, add your script machine, click new, save it, and then you can add the name and everything there. Okay, now let's actually jump to the next bit where we're going to create our graph. So we want to add some variables to our script machine. We need a variable called offset, right? And we also need a variable called follow object so we know what to follow. So just like we did before, or like we assigned earlier, on this variables field, right here, I'm going to click and type follow object and click the plus key to add it. And now there's a type dropdown. So I'm going to set this type to game object. Pretty standard. That's what we're looking to use, right? Then I'll hit plus, click here again, and I'll make a variable called offset, and I'll click the plus key right here. And in this dropdown, I'll go to vector3. So now we have a vector3 variable called offset and a follow object called game object slot called follow object. Words getting hard, y'all. But that's now our variable declaration that we've got set up here to work with inside of this. Okay, so you're, again, in the variables component, you're going to type one, hit plus, change it to game object, type your vector3 or your offset, hit plus, change it to a vector3, and that will get your variables added. So if you're following along via video, great time to pause. Okay, let's jump to the next bit here. So now we actually want to dive in and start using our node editor to create some code. So now that we've created this, if I go down to this script machine component, click edit graph, it's going to load up here into my graph editor. And you'll notice I've got two events here. I've got on start and on update. So I will simply click on start and delete it. Easy enough. So this is our first step to getting our node editor or script editor ready, excuse me. We also want to make sure to add our variables into the graph window. So to do that, if I go to in the Blackboard area here, if I click on object, you'll see there's the variables I declared. To add them to this, we just left click and drag them in, left click and drag it in. And so now I have my follow object variable and I have my offset variable waiting right here with my on update event sitting right here. All right. For the next steps, then, what we'll do is we'll scoot right along here, and we want to start setting up different variable connections, right? And we need to get the position of our follow object. We need that data to make it work. So inside the graph editor, which you're looking at here, you'll notice that there's inputs in these nodes and there's outputs. So if I go to my follow object and I click on the output and drag it over, I get this green line. And if I release it into the graph, it actually opens up the node selector where I can build different nodes. And so I'm going to search for transform, and it should give me a get transform, I believe. You know what? Let's just be even lazier. Let's just have for get transform. So then if we scroll down here, I'll do this. Actually, can we do transform get position? There we go. Transform get position. So when I select that, it's going to connect these. So what this is saying is, hey, whatever this object is, this game object, find its transform, which every game object has, and get me its position, right? So it's a get position node. So now that's all set up. We're going to want to add this position, and we're going to want to add it to our offset node, right? So we're going to use an add node. So what I can do for that is I will left click from the output of my offset, and I'll drag it in here, and I'm going to search for add. And there should be an add in math vector 3. So if I select that, it's going to give me first, okay, so your offset is A. Then I can grab the output of get position and snap that into slot B. And now we're adding these two values together, the offset and the position. So the position of the follow object plus the offset is what we're getting here. Okay. So I'll let you kind of set that up if you're following along. So again, you're going to left click out of the output, do a transform.getPosition node. Then you're going to go from the other one and make sure you add those two together. So we're adding the offset to the transform position of the object we're following. All right, let's finish up these nodes so we can get this finished up. So now we need to set position, basically. So now we need to tell the object this is attached to, like, hey, this is where you are, right? And we're doing this on the camera. So what we can do is I'm going to grab the output of this add, left click and drag it into here and drop it. And I'm going to search for set position. And you'll notice I'll have this transform set position. And it says this right here. In code, this means whatever I am. So this is going to be the object I'm attached to, set my position. And then this is going into the input. So this is the position it's setting. So all we're doing here is saying, hey, transform, set my position here. But now we need this to fire at a certain time. And you'll notice on this on update event, there's an arrow coming out of here. So this is our event. So if I grab on the arrow with a left click, I can connect these two events here. And now every time the on update event fires, transform.set position is going to pull all of this data and it's going to set the position like we asked it to. So this is our first basic visual script that we've created to make a behavior happen. Now, the last thing we want to do is set those variables and we'll test to see if this works. So jumping here, now that I've done this, I've saved it. I'm going to close, select my camera, left click and drag my vehicle into the follow object slot, set my offset to 5 and -10 like we had with the text-based code file. And let's hit play and see what happens. This is either going to go wonderfully or it's going to go terribly. But if it goes terribly, we'll just troubleshoot it. It won't be a big deal. All right. And look at that. Drove my car right off the cliff. The camera's following as I fall forever. And the nice thing is, I believe since this is at runtime, we should be able to look at our graph and you can see the data flowing. So every time, every tick, every update, 1, 2, 3, 4, you see this data all propagating and moving right into here so we can see it's actually working. And we get a visual representation of our code, which is really, really helpful for troubleshooting because we can see our data flow as it works. Also, I'm going to turn this off so my car doesn't fall eternally because that would be scary. Can you imagine being in a car falling eternally? That would be super scary. Okay, so now you've seen kind of how that part is created. We focus on visual scripting for this one. We've gotten some interactions moving. Hopefully, you're thinking, hey, I want to do more stuff. I want to learn more Unity, right? So we should probably talk about how you can do that. And one way you can do that is by going to learn.unity.com. This is a free resource we set up for anyone that wants to learn how to create games in Unity. And it'll get you started, right? This has a ton of content. It has, come on, let me skip. It's got 3,400 plus tutorials, tons of projects and courses, over 1,400 hours of content. It's got career development series and an educator's hub for those that want to teach this on how to teach Unity so you can start building out classes and programs. Again, that's learn.unity.com. It's totally free. I absolutely think you should go to it and check it out. Also, we have a really amazing promotion happening right now for student plans. So all students get free access to the Unity editor. Didn't know if you all knew this, but you do. And I'll drop this link in chat. If you go to this link and sign up for the student license and you're going to a school and you're over 16, you get a free Cinti asset pack. You get 6 months of Layer AI Pro, and you get access to Odin, Inspector, Validator, and Serializer as a student. Super powerful software to help make your game dev journey easier. But you've got to sign up in the next 2 weeks to get that. So if you're a student, you're watching this and you're like, oh, I need to get this now, sign up for the Unity student plan. You'll get set up with some really cool stuff. And finally, let's connect. The left is a bunch of Unity resources for you. The right is my social media. And the middle is how you can connect with Kaylin and the recruiting team to talk about what we've got going on career-wise at Unity. So please check that all out. And thanks for coming through and hanging out with me, everybody.